Oh, hello. Mr. Lee here. All right, here's numbers 23 and 24. We're dealing with imaginary numbers. So the first one says simplify I to the 51. So this is the type of problem where you have to relate it to your your values of I to the 1, 2, 3, and 4. So I to the power of 1 is just I, right? Which is the same thing as what? Square root of -1, right? That's our definition of imaginary number. If we do I squared, right, we take that square root of -1, we square it, you get a -1. I cubed gives you a -I, right? You're just taking the last power of I squared, multiplying it by another I. So this is -I. And then I to the power of 4 should give you -I squared, right? Again, we're taking this -I, multiplying it by another I, and I squared is the same thing as -1, so negative of -1 gives you +1. Okay, so this is something you can memorize, but even if you can't memorize it, right, you can always just reproduce it yourself. Okay, so I to the power of 1 is I squared is -1, I cubed is -I to the fourth is back to +1. Okay, so what we have to do now is figure out I to the 51. So this is just going to keep repeating, right? So if I go back to I to the 5th, that's there. This is I to the 6th. This is I to the 7th. And then, what did I do here? I to the 7th, and then this is I to the 8th. So basically any multiple of 4 gets you the same I value from its original power, right? So I to the power of 3 plus 4, which is I to the 7, this is the same thing as I to the 3, right? So we're going to figure out where 51 lies. Okay, so if you go multiples of 4, we have 4, 8, 12, 16, 20. Okay, I'm going to fast forward all the way to I to the power of 48, I to the power of 52. Okay, so I to the power of 4 should be the same thing as I to the 52, which then means I to the 7th or I to the 3rd is the same thing as I to the 51. That's what we're looking for. Okay, so we're going to look for this answer. And I'll write it just all the way up here. So I to the 51, actually I'll go to the bottom. I to the 51 should be equal to -I. Okay, that's a simplified version. Number 24, you want to simplify this fraction. You have an I in the denominator. So in order to simplify it, we don't want I in the denominator. So there's this thing where you multiply by the complex conjugate, right? So we can only multiply by a value of 1. The conjugate of 8 minus 4i will be 8 plus 4i. And we have to take that over itself, basically. Because if we multiply by this, that means we're multiplying the original expression by 1, which keeps the same meaning of the number. We always have to do that. But it will in turn change the way this expression looks, right? And it'll eventually be simplified. Okay, so let's work our distribution. You should get 40 plus 20i on top. And then on bottom, you get 64. We'll work this all out. So plus 32i minus 32i minus 16i squared. And then let's go ahead and simplify this. So what? 40 plus 20i all over 64. The 32i and the minus 32i, that cancels out. And then minus 16i squared, you should get a plus 16. So this becomes 40 plus 20i all over 80. Which then gives you 40 over 80 plus a 20I over 80, which you can further write as, you could write it like this actually. So 20 over 80I, and that's where your 1/2 plus 1/4 I comes up in your answer key, right? Which is just the simplified version of your original expression here.